Alright, so we're going to start to show the parabolic path has these equations of x and y. So we're going to start with x double dot and y double dot. And what we might do is for this, so this is 20, let's make this alpha. So this is 20 sine alpha and 20 cos alpha. So these are the initial velocities. So I'll put alpha for the angle, even though we know that, so the angle is inverse tan 4 on 3, the angle of projection. All right, so let's start with x double dot. We know x double dot, so the acceleration in the horizontal direction is 0. The acceleration in the vertical direction is minus g. All right. And I think they're going to use gravity as 10, but I'll do that at the end. All right, so if we differentiate this one, we're going to have a constant, and the initial and the horizontal velocity we know is 20 cos alpha. And if we integrate to find x, we have 12t cos alpha plus the c, and the c will be 0 because we're starting at the 0, 0 point, so x is 0. Y is 0. If look at that in a second. All right, so y dot is minus gt plus plus c in the original. So when t equals 0, the original vertical velocity, 20 sine alpha. So y we would get minus gt squared on 2, 20t sine alpha, and at 0 we're going to start at 0 for the y value. So if we just have a look at this, if you were, if we do alpha here, I'll put alpha here and look at this here. So tan of alpha, the old age, so it's a 3, 4, 5 triangle. So you can see that cos alpha, always high, is going to be 3 on 5. So I can put that in here, 20t times 3 on 5. So divide by 5 is 4, 4 3 is 12, so that's 12t. Same with here, let's make the gravities 10, so this is going to be a negative 5t squared. And over here we're going to get 20t, and we're going to get sine alpha, which is from that triangle, it's 4 and 5. So that ends up being 16t minus 5t squared. So we've got the equations that we needed to get. All right, hence find the horizontal range of the ball and its gravity. Well, let's find the horizontal range first. So we want to find that distance there. How do we find that? Well, we know at both this beginning point and this end point, y equals 0. So let's start with y equals 0. All right, so when y equals 0, let's sub that into the y equation, which is up here. Actually, which is down here. Okay, so putting 0 in there, we get 16 minus 5t here. So you can see that at time 0, of course, the height will be 0, but also at time 16 on 5, it will, that's at that point there. So now what we can do is look at the x value at that point to see how far it's gone across. So we're looking at this equation here. So x equals 12 times 16 on 5, and that will give us 38.4 meters. Okay, so that's the horizontal range. So what about the greatest height? So we're looking at the first we've got to find the time when that happens at that point, and we know when it changes direction that the vertical velocity is 0, so we're looking at the y dash equation. So we're looking for where y dash equals 0. So if I go back to y dash, which is this one here, so y dash we want to make 0, so we've got 0 equals minus gt, so that's minus 10, remember gravity is 10, and we've got 20 lots of sine alpha, which was the 4 on 5. So we've got minus 10t plus 16 equals 0, so you can see t is going to be 16 divided by 10, so 1.6 seconds. So that is the time that that greatest height is going to occur. So what is that greatest height? Well, we need to then put it in the y equation, which is that, whoops, that one there. So we've got at that time, y is 16 lots of the time minus 5 lots of the time squared. So putting that in the calculator, you get 12.8 meters. So 12.8 meters is the greatest height. All right, so part C, suppose that the ball is thrown up the road, the road's inclined, so the gradient is 1 over 5 because tan theta is the gradient. So inverse tan of a fifth is a fifth. So we've got this line here is y equals 1/5 x, y equals mx. All right, so we know that. So the ball is about 9 meters above the road when it reaches the greatest height. So we really want to know here what that y value is. So we need to know the x value at this greatest height time. And then sub that in to find the y value in this equation here. So at that greatest height time, so your working out should be a lot better than mine, I hope. So you're keeping track of what all these answers are. So at that time, what do we have? So our x value is 12 times t. So we're going from there. So we will get 19.2 meters. So at that time there, x is 19.2 meters. So if we then put it into this equation here, we've got 1/5 of 19.2. So our, let's get rid of that. So a 1/5 of 19.2 is 3.84 meters. So this is on the road is 3.84, where our greatest height is 12.8. So the difference between those two is 12.8 minus 3.84. So it's actually 8.96. So it's approximately 9 meters difference. So the ball is about 9 meters above the road when it reaches the greatest height. Yes, we've shown that. All right, so then what do we have to do? The time of flight, we've got to show the time of flight is 2.72 seconds. All right, so, and this is the ball going up here and then going to there. And find correct to the nearest tenth of a meter the distance the ball has been thrown up the road. So this distance here as well. All right, how are we going to do that? Well, we know that this is the equation, y equals 1/5 x on that road. So if we put our x and our y equation into that, so let's do that. See if we need that. Oops, I just rubbed our x equation out, but I think it was 12t, so we should be right. All right, so our y equation is minus 5t squared plus 16t. And we're going to make it equal to 1/5 of our x equation, which was 12t. All right, so putting that, timesing by 5, 16t times 5 is 80t, minus 5t squared times 5 is minus 25t squared. Don't know why I changed their order. All right, putting it all on one side, we're going to get 25t squared minus 68t's. If I factorize that, I get 25t minus 68 there. So you can see that's going to happen when t is 0, but which you'd expect they would meet when t equals 0, but they also meet up here. That's the one we're looking for. So we're looking for the one that makes this bracket 0, which is 68 on 25. So that's going to be 2.72 seconds. All right, so we know that the time of flight is 2.72 seconds. And so how far up that road is it? Well, let's have a look at our x and our y values. So x is 12t, so 12 lots of 2.72s, it's 32.64. And our y value at that time, so minus 5t squared plus 16 lots of t's Putting that in the calculator, you get 6.528. So up that road, you can see we've got the x value here, 32.64, and the y value here. And we're trying to find this distance here, so we're just using Pythagoras. So the square root of that squared plus that squared should give us the distance the ball has been thrown up the road. So when we do that, we get 33.286, something like that. So approximately equal to 33, so it's just one decimal place. So 3 meters up the road. You can set it out better than I can. All right, hope that helps.